Hello everyone, welcome to Physmatica. Let's take a look at this problem. The problem states, let n be positive and also n doesn't equal 1. Evaluate the amount of r. So for the start, I'm going to take a look at this scary argument right here. Let's just write it. I have a logarithm with base n, and then we have multiple radicals with index n, and the most inner one is just like this. So the first thing you need to know is that if you have something like this, we can just simply write this whole thing as a to the power of m over n. So let's just use this rule right here and see what we get, and always start from the most inner one. So I'm going to get, if I have this from this one right here, the index is n, so it's going to be n to the power of 1 over n. So now let's add the other one. Now let's add and extend this rule for the second radical. So what I have is this n to the power of 1 over n with this index n right here. I can just simply say this is equals 1 over n2. And now we can just simply do this two more times, and we can see that this logarithm is going to look like this: n to the power of 1 over n to the power of 4. And that's it. That's whole complex and scary argument here. This logarithm is actually this. We write it in a much simpler way. Don't get confused again. We have 4 indexes here. That's why we just did that n to the power of 1 over n4, because it was multiplied 4 times. So if I'm going to write a again, I can just rewrite a as minus 1 over 4 logarithm base n, and the argument for this logarithm is another logarithm with base n, and the argument is that n to the power of 1 over n to the power of 4. That's it. So another thing you need to know is that if we have a logarithm and the base is n, the argument is m, and argument is going to the power of something, we can just simply bring this power behind the logarithm. So it's going to look like this, and there is this alpha here. And another thing is, if m and n equal to each other, this is just going to simply be 1. So let's see what we have. We can simply see that these two arguments, n and n, are the same. So this is going to be 1 if we bring this behind this logarithm. So if I just again take a look at this inside argument, it's going to look like this: 1 to the power of n to the power of 4 logarithm n. Both argument and the base are the same, so this is 1. So all I have from this argument inside is actually 1 over n4. So I'm going to rewrite a again. A is going to look like minus 1 over 4 logarithm n 1 over n to the power of 4. That's it. So now let's see what we can do. We have 1 over n to the power of 4. So I can just simply write that n to the power of minus 4. So we can apply all these rules from here again. So it's going to look like this: minus 1 over 4 logarithm of n to the power of minus 4. I'm going to bring this behind this logarithm, so it's going to be multiplied by minus 1 over 4 multiplied by minus 4 logarithm of argument n base n. This is equals 1. We have two minuses, so this is equal 1 as well. So we can just simply say a equals 1. And that's the solution for this problem. Much easier as it looks. All you need to know is just a few techniques here and there. I hope you liked it. Thank you for watching.